Hi, this is Teacher Buxton. Welcome to Beginner Series. Before we continue, I would urge you to please make a subscription and we start what we are supposed to cover today. This series, these episodes do cover what we call surveying and construction measurement at large. From the previous sessions, we have covered a number of items. We have covered the rules of measurements. We've also covered the sections where these rules are found, and we already started taking off. So today I would like us to go straight into our coverage of trench excavations. So let's work together and let's see what we have in the coverage of the trenches, the rules that we need to know, and how to cover that from the drawings that are provided to us. Of course, making few assumptions here and there, but it's so crucial that we go straight into what we need to cover today. Talking of which, today the plan that we've been using is this, and from this plan it's ideal and it's quite crucial because as long as we can follow it properly to the end, it does not have a perfect rectangle. So it means the few challenges that you might find while going through the recesses or the extensions here and there, it's going to be covered. So this is the right channel to be, and let's follow through together. When you're talking about trench excavation, the rule is what we normally refer to. What does the rule say about this, or how do we go about this particular item? So we'll check straight to what is available for us to see. Trench excavation falls under excavations, and when you are wondering where you can find it, it's done in cubic meters, and the rule is found from section D9. Okay, from section D9, that is where you can find that particular rule that we are talking about in terms of trench excavation. So this is where you find it. That is item 5 in our item 5. Okay, item 5 allows for the trench excavations done in cubic meters, section D9, and we'll do it in stages of 1.50 meters. So we are going to see how that 1.50 meters, the stages, is going to be applicable, and how the cubic meters is going to be derived. So that is why we go straight into what we need to look into. So this is our taking off dimension paper that we are using, and we'll continue to use it as long as it serves our purpose. So this is a traditional dimension paper, of course. When you need to know some of the parts and how it's done, it's important that you are going to check our previous sessions, because all these items were done, and they were also given in terms of identifications of what is column 1, what is column 2, column 3, and column 4. So all those columns, in terms of how to identify them, have been given properly in those previous sessions. So let's proceed from here. You see, we are talking about the trench excavations. So it means we need to know that what is the extent of the trench, what is the length, the total length of that particular trench. Those are the very important items to look for. And of course, you need to check into the section. From this section, what do you have and what can guide you into doing it properly the way you are supposed to do it. So talking of which, in this trench, of course, the section gives you how you would view that trench from a particular elevation. Okay, the trench has been cut through. For instance, in this one, this is a plan to mean that it has been done above the ground surface. But then now below the ground surface is what we have been shown on the plan. So assuming that you would cut this particular plan in this, for instance, at that particular part, but then now below the ground surface. That is what you'll see from the trench section that we've been shown. So once you have this, then it's just important that you go through and calculate the trench, the center line for that trench, and then of course you'll be able to find what we call the length. But before that, I would like us to see the extent in which from the section you are able to relate that this particular plan has got spreads, okay, and the spreads are shown here. For instance, this is a spread, this part here, and then this is also another external spread. Okay, so the center line that we need is supposed to be coming through this at the center. Is supposed to come through at the center of this particular plan. Okay, so when we have that, then we can clearly see that we need to find out that center line from the plan and see what that length is translating into exactly between at the middle of this wall that is provided here. Okay, so let's find out how to go about that particular one. So in this case, of course, the length, we have the dimensions provided here. We have dimension 1 and dimension 2 as the length and also as the width. Regardless of the shape, you can always take the length and the width and the full length and the full width, then you multiply by 2 as if you are doing a perfect rectangle, and then do your adjustment. Of course, you will also find out the recesses, the ones that need to be added. So that is what we'll do. First we'll take the length, therefore would be, let's go straight to what we have here and calculate it now. Alright, so this is what we have. We are going to calculate trench excavation. Okay, so once you've done that, just make sure you underline. You underline what you have, what you've done, the title for the trench as such. So once you've underlined your work properly, then you now go through how to calculate now the trench. So we are going to calculate what we call the center line. That is what is going to help us to calculate that volume for the trench excavation. So I've told you that for the center line of these, calculate, get the total length, the total width, multiply by 2, and then you will add the recesses. These are the recesses. So you will add them once you calculate your length to the external, to the outside. So a very straightforward way is that the length in this case includes 200 plus 10,800. So we have 200, then we have 10,800. Plus 200 plus 5,600 plus 200. So those are the dimensions that you're going to have, and of course you always remember to arrange your work in a way that if you've decided to push all the dimensions to one side, of course I would like us to use the length on one side and then the width on the other side. So this is supposed to be our length, and then of course on the other side we do our width. Yes, so from the width as well, let's see what we have. The width, we already gotten the dimensions and written them here. So we have 11,000 no, that is another part. Let's see the main bigger area. Let's just make our reference here. The main bigger area, of course, is here, 11,000 plus 200 plus 200, and that is what we have. So 11,000 plus 200 plus 200. So we have this. The first one is 11,000, and then we add the walls 200, and we also add another 200 there. So this is what we have. So we add both of them on either side. We get the length and the width, then we add those two and see what we are coming up with. So when we add these two, 200 plus 10,800 okay, just make sure you arrange them properly. We have that, and we have that, and then you keep underlining well as you should, and of course you need to also find out what these dimensions bring you. Okay, so that is what we have. So this is 11,200 plus 5,600 plus, so we add 200 plus 10,800 plus 200 plus 5,600, and that gives us 17,000 for the length, and then we go to the other side and have 11,400. So you add these two, you add what you have here for the 17,000, then we add to 11,400. When you add these two, you get now the two sides of this particular plan, and that is 28,400. 28,400. Then you need to multiply this by 2. Okay, so you just do times 2, 28,400 times 2, and then you get what is supposed to be the perimeter on the outside. Okay, so when you do 28,400 times 2, you get 56,800. 56,800, and then you now add the recesses. So these are parts of the plan that are going towards the main area of the plan is what we call the recesses. Okay, the ones that I indicated here. So you'll add the two recesses, because when you see, even if you try to fill, the reason that we normally pick these parts and assume that they are going to be, we are going to use now the main formula of calculating a perfect rectangle is this. So if you're, in case you're wondering how that is coming about, I just want you to have a look at what I'm going to illustrate here, and then you will see what why we can always use that alternative to find the length. So if you check through, if you look at, I want to use an arrow to show for instance, when you look at for instance that one area that or that one arrow that I've shown, when you take this particular part, the particular part where the arrow is emanating from, and then you transfer it theoretically to this particular point here, it's supposed to give you a perfect plan. So you assume that this part is going to be transferred to where I've shown. Okay, part X transferred to part Z, okay, in that point, and then part 2, and then you transfer again here upwards to this particular point in that part. Then you're also going to have that part filling that given area, and then again you have this part being transferred upwards to that particular area. So you have this part at the lower point, and the part to the one that I've just shown now transferred to that particular part. Then you are going to have a perfect rectangle. Then, notwithstanding, there is this given part, the one that are called now the recesses, that are going to be hanging, this part here and this part here. So in that case, that is why we need to add them separately, because the other areas are going to be filling the remaining part of that plan to make it a perfect rectangle. So if in case you are wondering why we have to add the recesses and the other parts have not been catered for, then that is the reason. So you transfer those, you try to transfer them theoretically and find out what is left hanging out. So the part that is left hanging out is supposed to be of a length that is 3600, which is here. This particular part, they are 3600 each. So 3600, and we also add 3600 on the other side to get that total length. So if you add the recesses, both of them. So we'll just take the 5600 that we've gotten from multiplying this one by 2, and then the recesses now are supposed to be 3600, and then we multiply by 2, okay, and that is 7200. So we take this, and then we add 7200 to what we've calculated. So from there, when we add these two, 7200 plus 56800, you get 64,000. Okay, you get 64,000. So from the 64,000, that becomes the total. Yeah, so this is 64,000, and then we now less the four corners. The four corners, we take the full thickness of the corner, which is 200, then we multiply by 4. So it's 4 times the thickness of 4 times the 4 resembles the number of corners, while 200 is the full thickness of the wall. This becomes 800. So the reason why we are taking the 4 corners is this: when you go to this particular plan, you've realized that we got the length that is taking the full length from one end to the other. But then we don't need it from from the external faces. That is, we need it instead at the center of the wall, because that is the way I explained previously. We need it at the center, for instance, at that particular part. And then also we also need it on this other half. Okay, So that being said, then it means that is the length that we need. But then our calculation, the length is including the 200. The 200 is at giving you up to the external face of the wall instead. Okay, so when it's giving you to the external face, then you need to adjust that length so that it's adjusted towards the center. And the best way you do that is you take the full length as it is from the external faces. Or of course, if you go that way, then you deduct the 200 by 4. And this is how that one is coming about. From one corner, from one single corner, you are going to take half of this 200. So it means you're going to take the full length and then you less 200 on one side, and then 100, which is half the wall, 100 on one side, and also another 100 on this side. Okay, so in one face you've taken 200. It means you've taken 100 on one side and 100 on the opposite side. Okay, when you come to this part, when you come to this other width, for instance the one that is to the left, what will happen is you also took the full length from top to bottom at the external faces of the external wall. But now we also need to adjust so that we take instead, we have it towards the half, towards the center of the wall. Okay, and this is how it happens. Leave alone that it's not from the center the way I would require it to be. I want that also at the center there, and the same thing I also want the same thing happening to this particular part. So we take the full length. Of course, we've taken the full length from the external faces of the external wall. Okay, when we do so, then we need to subtract half the wall to the top and half the wall to the bottom. Okay, so when we do so, then it means we are from this other corner again. From this corner again, you are going to subtract another 100 from that total length, another 100, and also another 100 to this part. So it means that you realize that from this corner alone, we've taken 100 times 2. Okay, so it means we've taken more or less the full thickness of that particular wall. But in real sense, we've taken 100 times 2. We've taken half the thickness of that particular wall times 2. The same thing is going to happen at this point, because when we get here that we need the other length at the top, then we are going to take another half of the wall and another half of the wall. So you realize that at every particular corner you are taking the thickness, you are taking the wall half, you are taking half that wall but twice. That is why in a more summarized way, you can take the full thickness of that particular wall and then you multiply by 4 corners. So despite the number of corners that you have, the relation of the 4 corners times the thickness of that particular wall still gives you the correct answer. So let's just continue. At the top again, you are going to take the full length from the external faces and then you less half the wall, half the wall. That gives you another twice half the thickness of that particular wall. When you are also at this point, you are going to do the same. Do another half and then do another half. So at the end of the day, you shall have taken all the halves at the corner twice. And a half times 2 gives you a full thickness of the wall. So without even more explanations here and there, you hear that we are going to take that given thickness, thickness of the wall, the full of it, times 4 corners. So despite the number of corners that you have, the rule of distance moved, which is now taking that particular thickness of that particular wall and multiplying by 4 corners, still gives you the correct answer. So that is why we need to adjust. And of course, the recesses, we are going to take them for the reason that I mentioned that at these particular areas, those particular parts have not been taken into consideration while trying to fill up this rectangle, this shape into a perfect rectangle. So that is how we go about that. So what that means is that now we are going to less the corners. And also, just as a reminder, you realize that we have taken all the dimensions from the external faces, and that should even apply for the recesses. So for the recesses, we take the full dimension from the top, from the external faces of that particular wall. That is what's going to give us the correct answer. Therefore, in this case, it's going to be 3600, then we add 200 to give you to the face of the external wall. So if you add 200 here, it's going to be 3800. That is supposed to be 7600 in this part. Then you now add 56800 plus 7600, that is 64400. And then we now less the corners. Corners is we've said it's the whole thickness, which is 200 by 4 times 800. So this is supposed to give you 63600. So that is what we are supposed to have as our center line. So just write it here. Actually, just indicate that this is now center line. Yeah, the essence of having your center line correctly worked out, because you're going to use it even in other subsequent items like concrete. You're going to rely on that. When you're doing your blinding, you're also going to rely on that. So you'd rather spend just reasonable time and work out the center line in the most correct way that you can, because it's going to give you more accurate answers going forward. And there are also those number of items that I've mentioned which rely on correct center line for their workings. Items that I've mentioned, like the blinding and so on. So that is what we've discussed. And just to make a recap of the same quick fast, this is what I will do in my summary. In my summary, I will mention that when you need to calculate the center line for shapes that are not regular, then it's important that you know that all the shapes are always going to break down at the end of the day to a four-sided rectangle. So when you use the what we call the rule of distance moved, then you notice that when you have your dimensions, you can have your dimensions from the external faces of the external walls, all of them, including the recesses. So you simply calculate the perimeter of a perfect rectangle, okay, by having your dimensions from the external faces. Just calculate them the way you will calculate the perimeter of a rectangle. Okay, that is the length by width times 2. Okay, after that, then you add also the recesses. You add the lengths for the recesses in the manner that they're also from the external faces of the wall. Okay, the manner that they're also external faces of the wall. That is, from this side, the way we have it here is 3600, but then you add 200, and 200 is up to the point where you're having your face of this particular wall. From that point, so we have 3600 plus 200 times 2. Okay, that's going to give us the perimeter from the external faces of that particular wall. Then we less the corners. When we less the corners, they're supposed to give us what we need as the center line of that particular working. So that for today, we've just calculated, we've just done our explanation for the center line. And in any particular way, even if there are more questions that you might have regarding the same, then we'll always be able to explain that. So our center line for today, that is what we've calculated. And moving on to the next session, we are now going to calculate we are now going to add the internal lengths and also ultimately calculate the volume for the excavation of our plan that we have. So any more questions that you might be having in regard to what we calculated at the Centerline today, then I would urge you that you put the questions on the comment section. Just ask for more clarifications, and so that you understand it even better moving forward. So that brings us to the end of our coverage for today's session, and seeing you next, we are going to add even the length for the internal spreads, and I mean the internal walls that we have, the two of them, and then we now calculate the volume for the trench excavations. So thank you very much for keeping watching up to this point, and I would urge you that before you leave, please make a subscription so that you gain even more from this channel. Thank you very much. Have a great time till we meet again in our next session. Bye bye.